Hello, everyone. GM, good evening, good night, wherever you are in the world. Sorry about this slight delay, but we'll get right on it. So right now we have with us Sahil Sen from QuickNode, and today he will take you through how to build a cross-chain dApp using Chainlink CCIP, which is super interesting, and you can definitely apply it to our cross-chain solutions track. So pay attention, take notes. Feel free to drop your questions in the chat. Sahil will either go through them and reply as he goes, or we will take it at the end. But for sure, we will reply for your questions. So yeah, and with that, Sahil, I'll take it over to you.
Yeah, thank you so much for the introduction, Sophia. And as she mentioned, we will be going through CCIP and how you can create front-end applications using CCIP. So what we will be seeing today is this short, simple, basic applications. What this application basically does is, let me disconnect it so you can see the basic first-hand view of the application. Let me zoom in a bit. All right. So this is a very simple message sending and message reading application. But the thing is that it's cross-chain. So what this application basically does is you connect a wallet, MetaMask, um, connect a wallet, yes. So the wallet is connected. Right now, it's hard coded to only support two chains, which is Base and Sepolia, or Base Sepolia and Ethereum Sepolia. Let me switch to Base Sepolia. So what we will be doing basically today is we will send a message from Base Sepolia testnet to Ethereum Sepolia testnet. And as the image suggests, we this input box takes a message and sends it to Ethereum Sepolia from Base Sepolia. So let's send a message. So I am sending the message right now because it takes some time for a transaction to get finalized on CCIP because it first needs to go through multiple processes um, on the source chain, and then it needs to go through some processes on the destination chain. And then there is a verification process which also happens off chain. So that's why it takes some time, and it's cross chain. So of course it's going to take some time. That's why I'm sending the message right now so that maybe by the end of the workshop, the transaction is finalized and we can see the finalized message. But even now, uh, there is some message because the contracts were pre-deployed. We will deploy the contracts again, but to save us some time, I had already deployed the contracts. So the contracts are pre-deployed. The message right now is hi from base, and once I send a new message, this will change automatically because there is a React hook running in the background. So this will be our message, Block Magic demo message, because we are doing a demo at the Block Magic hackathon. So let's send the message to the Sepolia chain. So confirm it. We can view the transaction once it's confirmed on base Sepolia. Let's look at our transaction. It's still pending. It should be confirmed pretty soon. Okay, it's confirmed now. So all right, so this is CCIP Explorer. Over here, what we can do is we can look at our cross-chain transactions. And as you can see over here, this is our cross-chain transaction. And it's saying that the expected time to finality for this transaction is 32. It should be so shorter than that. It should not take 32 minutes, but that's the maximum expected time. Sometimes it can go over that as well. But over here right now, it's 32 minutes expected. So that's why I went over and did the message sending process earlier before explaining and going through any of the stuff, so that we can get some time for this transaction to get finalized. All right, so we will leave it here and then go to our code and CCIP contracts. So, but uh, first, let's understand this CCIP contract, what this is doing, and then we will understand how the app is built, how the app is interacting with this contract, etc. So this contract is basically a CCIP message sending contract. I have taken this contract from CCIP documentation itself, so it's not a new contract, not anything complicated, no rocket science, nothing. It's a basic CCIP message sending contract. So we are importing a bunch of CCIP contracts over here, like router contract, owner is creator, then client contract, CCIP receiver, IERC20 and SAFE ERC20, which helps us work with ERC20 tokens. And then this is the contract messenger, and we send the contract or we deploy the contract with the router address and the link token address for that particular chain. So we will have to deploy this contract on two chains, which is base chain or base Sepolia testnet and Ethereum Sepolia testnet, because the contract on the base Sepolia testnet will work as the source chain message sender contract, and the contract on the Ethereum Sepolia chain will work as the destination chain message receiver contract. So after declaring the contract, we have a bunch of custom errors declared over here, which will be emitted if that particular condition is met and if an error occurred. And then there are events, and then there are mappings and some variables. So over here is our actual constructor, which we are initializing with CCIP receiver. And then there are few modifiers, and then there are functions. So these are the functions which we will be actually using. So we will be using a function called allow list destination chain, where we will allow list a destination chain. Okay, I'm sorry about that. Let me increase the font size. Yes. So we will allow list a destination chain, which will be Ethereum Sepolia in our case. And we will allow list that chain with the help of CCIP chain identifiers, which looks something like this. You can see over here, it's a string of big number. It's a string of uint 64, if I'm not wrong. An unsigned integer 64 bit. So it's a big number. So that's where VM plays a big role, because it supports browser native big numbers. So, but that's for later. So we will call a function called destination allow list destination chain by passing the chain identifier of Ethereum Sepolia testnet, which is this one, and a Boolean value, which will be true. And on the other side, on the Ethereum Sepolia side, we will allow list a source chain, which will be base Sepolia testnet. And over there, we will need the chain selector for base Sepolia, which is this. And again, a true value. Then finally, in the send message or send message pay link function is the message which helps us send the actual message. And in that, we have the destination chain selector, which is again the chain selected string of numbers. And then the receiver's address, in this case, which will be the address of the contract deployed on the receiving chain, in this case, Ethereum Sepolia chain. And then there is the actual text message, which is a string, whatever we want to send, which you can see over here. All right. So that's there. And then there is a read function called get last received message details, which is a read function which is used to read the message stored on the contract or read the last stored message on the contract. And it gives you the message ID and the actual text of the message. So that's what we are doing over here. By calling send to Sepolia button, we call send message pay link function, and by calling read on Sepolia button or clicking on read on Sepolia button, we call get latest received message details. But it's better to show than just talk. So let's first deploy the contract, and then all right. So to deploy the contract, we will need to deploy it on two chains. First will be base Sepolia, and then the other will be Ethereum Sepolia. So Chainlink CCIP. Right. So it's compiled. Let me select. It's on base Sepolia. Yes. So I'll need a router address and link address. So the router address for base Sepolia is this. So router is basically a smart contract which is identified for a particular chain, and that will route the transactions for CCIP for that particular chain. So for base, the router address is this. So we will need that. And you will also need Chainlink's link tokens base address. Let me search base. Right. So this is the link on base. Because we will be sending message and paying in link. So once the contract all right, so the contract is deployed. All right, the contract is deployed. And what we need to do next is deploy it on Ethereum Sepolia. So let me quickly change the chain in my MetaMask wallet. Changed the chain, connect to MetaMask. Then over here, I'll need Ethereum Sepolia router address, which is this. Then paste it here. Then I'll also need Ethereum Sepolia link contract address. Right. Deploy the contract. Okay. So this will be our receiver chain contract. This will be our sender chain contract or source chain contract, receiver / destination chain. So this is deployed on destination or receiver chain as well. Let me just copy the contract address because we will need to allow list the destination chain. So, oh no, we will need the destination chain selector, which is the chain selector, which is this string of numbers. So let's just copy this because that's the chain selector for Ethereum Sepolia, and that's the destination chain. And you need to set the Boolean value as true and send that as a transaction. That's there, connected. And on the Ethereum Sepolia side, first we will allow list the source chain which is base chain or base Sequoia chain in this case. Okay, so let's just wait a second for the transaction to get confirmed. Okay, it's confirmed. And now the next step would be to allow list the sender. Sender will be the sender contract. So let's copy the contract address on base Sequoia, paste it here, then set the Boolean value as true, then send the transaction. And since we will be using send message pay link function, we will need to send some link tokens to the contract so that it can pay CCIP for the cross-chain transaction. And you can pay your pay for your CCIP cross-chain transaction in native tokens as well. For example, on base it will be ETH on base. For Polygon it will be Matic on Matic on Polygon, and for Ethereum it's Ethereum ETH as well. So like that. So let's send some link token. I mean, we won't be using this contract because we already have a contract, but I'm just showing you a flow if you were to deploy your own contracts and how that process would look like. So I'm just sending some link to the contract so that the contract can pay for the cross-chain message sending transaction. Okay, so that should be done. Now let's talk about the app itself. And the app is using two major libraries apart from the traditional ones, which is, I mean, even these are traditional right now. I mean, a lot of people use them. They are very popular. So we will be using viem and wagmi. So wagmi is basically a React-based hook library for Ethereum-based applications where you can I'm sorry, where you can create Ethereum, where you can create React hooks for Ethereum blockchain or on Ethereum blockchain, and you can create React frontends using Wagmi very quickly. It helps you interact with smart contracts very quickly. It has inbuilt 20 plus React hooks, for example, to get chain IDs, to get ENS names, to read contract, to read wallet addresses to send transactions, etc. And the entire Wagmi library is based uh, on a custom Ethereum client, which is called viem. And viem is very much faster compared to our other libraries like the 3JS or Ethers.js. And it's very much lightweight. It's built by keeping browser applications in mind. I mentioned earlier that big number or big number is native to how big number doesn't need any other libraries to be imported to work with big number in VM. You can type in browser native bigint and it will work with VM applications. And it's modular so that it works with not just React but also with vanilla chains. So let's go into our application. This is our main index page where, of course, we are importing React elements first, and then some import statements for Rainbow Kit, because since we are using Rainbow Kit for our wallet interactions, so these are few import for Rainbow Kits. Even this is an import for Rainbow Kit because our Rainbow Kit app is this, and rank button is the actual application of Rainbow Kit, and it works Rainbow Kit works out of the box with WAGMI and VM, so you don't need to set up your entire wallet, entire window.ethereum connections, anything. You just have to pass in this little uh, little configuration and it will work. And then we are importing few WAGMI functions like WAGMI provider, HTTP, and importing WAGMI chains like base Sepolia and Sepolia, which we'll be using. And then finally, we are importing the contract interaction application, which has our logic for contract interaction, both reading and writing. We'll go through that later, but first let's just understand this. So over here, what we are creating is we are creating a wallet connect ID. We are creating two other variables which will store our RPC URLs for Sepolia and base. We are using QuickNode over here. So we are using QuickNode because we don't want to get rate limited. We don't want to use public endpoints or public clients which are already there in VM. Even VM documentation suggests that you should get your own private endpoints so that you never get rate limited. So once you are in your QuickNode dashboard, you should create base Sepolia and Ethereum Sepolia endpoints. And once the endpoints are created, they will look something like this. So once you click on the endpoint, you just need your HTTPS endpoint in this case because we are just connecting. So we will be using our endpoints or endpoint URLs for two use cases. One is to interact with our wallet. Our wallet will be using our QuickNode URLs as well. And second is to interact with our smart contract to send transaction and to read from the contract. Right? So this config is the configuration for our Rainbow Kit wallet. So the app name is just Rainbow Kit demo. Project ID is Wallet Connect ID. And then chains are base Sepolia and Sepolia. This is how you declare chains in WAGMI or VM. And transports is basically how you can set your custom HTTPS URLs. So we are creating base Sepolia ID from base Sepolia URL and Sepolia ID from Sepolia URL, which we got from environment variable. So basically our Sepolia endpoint URL, base Sepolia endpoint URL, and wallet connect ID are all stored in environment variable like this. And then we are getting the root of the application by ID for the React DOM and query client. And then we are rendering the entire page, which is first the app, which is the Rainbow Kit app, and then SCI, which is our smart contract interaction application, which contains all the logic for our smart contract interaction. So now let's go to our smart contract interaction.tsx, where we are first importing few functions from React, which is useState and useEffect. UseState will be used to get useState will be used to get or store the state functions or state variables, and for React, and useEffect will be used to trigger a function after some time. All right. Then we are importing few stuff from client file, which is this. So to use our QuickNode variables, sorry, to use our QuickNode endpoints for base Sepolia and for Ethereum Sepolia, and to use our window wallet to send a transaction, we will need to create a client file and pass those variables, pass those values into some particular function. We will see how. So, create public client is a function of VM library, which is used to create an RPC connections, and create wallet client is used to create a wallet. That wallet is basically a wallet which can be used to sign transactions and send transaction. So again, two variables, base Sepolia URL and Sepolia URL. We are getting the actual values of them from environment variables. And then this base client will be create public client, chain will be base Sepolia, and the URL will be base Sepolia URL. So whenever we want to use the base client, base chain RPC endpoint, we will use base client. And the same is for Ethereum Sepolia, we will use Sepolia client. Now for wallet, create wallet client. We are initializing the wallet just for base Sepolia chain because the source chain or the sender chain is just base Sepolia. We will be sending a transaction from base Sepolia. We will only be doing reading of data on Ethereum Sepolia, so we don't need a wallet on that chain. And then we are telling VM that use a custom wallet, which will be window.ethereum. In our case, wallet, whichever wallet which is connected to our Rainbow Kit. So let's go back to contract interaction file. All right. So this was these were the modules or functions which we created in our client file. And then comes the ABI. So since we will be interacting with a smart contract, we need ABI as well, because a smart contract is compiled and stored in a bytecode format on a particular chain, because smart contract we write in Solidity, and the EVM, which is at the end of the day a machine, cannot understand that smart contract out of the box, right? So it needs to be converted into a machine readable or machine understandable format, which is bytecode, and that's how it's stored on blockchain. But since blockchain is a closed environment, EVM is very much different. Our JavaScript compiler or React compiler is very much different. So React compiler, where our app is, it does not understand what that bytecode means, which is stored on EVM chain, or in this case, base Sepolia or Ethereum Sepolia chain. So for our JavaScript or React compiler to understand what's going on within that smart contract, there needs to be a interface or bridge between bytecode and our JavaScript application. So that's what ABI does, as its full form is literally that, application binary interface. So it's an interface between application, which in this case is our React application, and binary, which in this case is the bytecode or binary code stored on the blockchain network. So it's an interface between our application and binary stored on blockchain. And it helps our React application or JavaScript application to understand what's going on with the smart contract. So what we have done is basically just created a variable called ABI and stored our entire ABI within that variable. and then we are just exporting that variable, like how we export any variable or function output in React. You can get ABI while you are compiling your smart contract by just clicking on ABI over here if you are using Remix as well. All right, and then we are just importing some basic CSS styling, which is this. So we have style buttons and input fields and labels, etc., etc. over here. All right, and these are like few straight variables which will handle different input values, different message values. For example, over here we need a state variable because earlier the message will be something else, then it will be something else. Then we need a state variable for transaction hash because earlier there won't be any transaction, and when we send a transaction, there will be a transaction hash. So there needs to be state variables to handle those state changes. And so the first state variable is to handle the input value, whatever we input over here in the input box. In this case, block magic demo message, what we have inputted. And then this will be the contract message, which is what we send to the which we oh no, sorry, contract message is what we get from the read contract function from the Ethereum Sepolia side. So earlier it will be empty, but as soon as we execute that function, execute that read function on Ethereum Sepolia contract, we will get some value, and then it will be set to contract message variable. And in show message, set show message, it will be the message whatever we show in the front end. It will be the exact message which we get from contract message, but we will just show the text message because we saw earlier, right, in the smart contract that when we read latest message details, we get two values in return. We get the message ID and then we get the actual text. But in the front end, we won't be displaying the message ID. We will just be displaying the actual text. So that's why we need different state variables because we will be storing those values in them. So first, let's talk about the input field and send to Sepolia button, right? So what we are doing over here is first, we are handling the input change. So whenever someone inputs something, it will set the input value so that the input value is then stored in this input value variable. And then we will be using a log input function for form submission, which is whenever someone clicks on send to Sepolia, this function will be executed. And all of that you can see over here. So this is our structure for our app, which is first application, then there is a form, and then there is an image for our base chain image. And this is the input field, where the value will be input value, as we saw earlier. And one change, we will handle input change. And then there is a button, and on click, we will log input, which is this function, which we saw, or we will be seeing in detail now. And then we end the form, and then we create a new div container and add another button because we don't need a form because now the next button is just the read function, so we don't need a form. And then there is this paragraph element of HTML, where we will be showing the message, which is this. And then there is another paragraph element where we will be getting the transaction hash once the transaction is sent and prefixing it with https slash like colon slash slash ccip.chain.link slash th slash whatever the transaction hash is, so that it takes us to CCIP Explorer's that transaction page. So let's talk about log input, which is the function which will be called once the form is submitted or sent to Sepolia. This button is clicked. All right, so it will first like just console.log, which is print the value of input value or whatever the message user input in console, and then it will await for send transaction function to get executed. Now let's see what send transaction function is, because that's the function which will send the transaction from base Sepolia to Ethereum Sepolia. So what we are doing is we are declaring a new array called account, and we are getting the address of whatever wallet is connected to our Rainbow Kit wallet connect client, which we declared in client.ts over here. So our wallet connect client is basically window.ethereum, which means whatever wallet which is connected. So we are getting the address of that, and then we are simulating a contract. So simulated contract is basically a function of VM where you can send a transaction to a contract. So we are forming a request, and in that we are passing few values. So the address will be the address of the contract which we want to interact with. In this case, this is the contract which is stored on base Sepolia chain, and this is the ABI, which is the ABI we store in ABI.ts, and the function name will be send message pay link. We saw this function right over here. Send message pay link. So it takes three values as parameters. First is the chain selector. Second is the receiver, which is the receiver contract address. Then the actual string of the message. So that's what we are doing over here is we are hard coding two values, which is the chain selector. And as I told you earlier, in VM, you can use native BigInt identifier or modifier. So BigInt, this is the chain selector for Ethereum Sepolia, since that will be the destination chain. And this is the address of the smart contract on base on Ethereum Sepolia, on base Sepolia. This is the contract on base Sepolia, which is the sender contract or source contract. This is the contract on Ethereum Sepolia, which is the receiver contract or destination contract. So we are hard coding the chain selector value and smart contract value, but we will be getting the message value from the user. And then we are passing the account, which will be the address. So now we are sending this as a transaction. So it like we are using the wallet client to write to contract, and we are passing all the values which we stored in the request variable or request object. We are passing the request object as the parameter. So all of these will be the parameters. And then once the transaction is sent, we are logging the transaction response over here. And we are getting, so basically we will just get the transaction hash as the response, and we are saving that and set transaction hash. And since that's a state variable, transaction hash will be saved in transaction hash. And then we are over here for debugging, error logging. We are also printing the transaction hash in the log or console log. And this is just basic error handling capture. So this is how we send the transaction. And now on the base Sequoia side, we do this. We send the transaction, and this will be the right transaction. But before doing that, make sure to send some link tokens to your smart contract, which is this smart contract saved on the base Sequoia chain. Now let's go back to the beginning of the code, which is over here. So now once the message is sent, we also need to read the message, right? So that's what we are doing over here is we are using another function of the VM library is read function. So we are passing address, ABI, and function as parameters. So this is the contract address on Ethereum Sequoia. We are using ABI, and then we are also using the function name, which is get last received message. So we basically need three things to interact with a smart contract in any library, not just this, but with any library, even in ethers. We need a RPC, we need a smart contract address to identify or locate that smart contract on that particular chain. Then we need ABI for our app or client to interact or understand that smart contract. So that's what we did in the right transaction as well. We used base client, which is our base Sequoia RPC. We use this contract address to identify our contract on base Sequoia network. We use ABI for our application to understand the smart contract. And that's what we are doing here as well, but for Ethereum Sequoia. So by executing this function, we will get some data back from the smart contract or Ethereum Sequoia chain, and the data will be message ID and the actual message text. So we just want the message text. So we will get the one index position of that received data. 0 index position will be the message ID. 1 index position will be message text. And then we will just do basic error handling by using try, catch blocks. This is what shows us the message in the front end. And that's why we are using use effect to hold that message to be shown in the front end until and unless this button is clicked. Because that's where we are setting the show message as true, but because its default was false. And then we execute that function, handle read click, and read on Sequoia button, which means that the message will only be shown once the button is clicked. Because since this is a read function, the message will be read as soon as the app is loaded. Because someone said, could you please go over the imports used? Yes. So the first import used in this particular file are use effect and use state functions of React, which we want to use because we are using user given input variables or some data which is fetched via API. So that's why we are using state variables over here. And that's why we need use state function and use effect because we are holding off our message display until and unless handle read click function is executed, which is executed when this button is clicked, read on Sepolia. So that's why we need these two functions. And then we are importing these three functions from the client file, which is wallet client, is basically our wallet connection over here. And as you can see over here, wallet client is our window.ethereum wallet, and create wallet client is a function of VM used to create a new wallet. And Sepolia client is basically our Ethereum Sepolia URL connection, which you can see over here. Sepolia client is our Sepolia URL connection, and base client is our base Sepolia connection. You can see over here. And then the ABI is, as the name suggests, just the ABI, which is stored in a ABI variable in abi.ts file over here. And then this is just some basic CSS. So these are the import variables used. And these were all the functions which we have used. So when we click send to Sepolia button over here, log input function is called. And in log input function, we wait for send transaction function to get completed. In send transaction function, we are sending the transaction with the input value to the base Sepolia smart contract, which is a CCIP contract, and which will send the message to Sepolia chain contract, which is stored on Ethereum Sepolia. So let's take a look back at our transaction which we sent earlier. Let me refresh it. So this says that it's committed, but it's not successful yet. So this should be successful in few minutes, very soon. So basically, this is how you can create your own front-end applications using VM and CCIP. CCIP is very powerful because you can create cross-chain applications. I have just created a front-end wrapper around those smart contracts because this particular input field is just taking user input and passing it as a smart contract right transaction parameter. And then in this by clicking on read on Sepolia button, we are just executing a read smart contract function. So this is just a wrapper around front end. Everything under the hood is working or is powered by CCIP, and those blockchain interactions, either for read or write, is powered by QuickNode RPC URLs. So let's look at our contract transaction. I'm sorry. Yeah. So it's still taking some time, but I won't take much of your time. But when the transaction will be completed, this is the updated message. Block Magic demo message will be updated over here. Once the transaction is completed, that will be updated over here. So thank you everyone who has been around from the beginning and jumped through the workshop. And if any of you has any question around CCIP, around VM, around the app which we saw, around QuickNode, feel free to ask now in the chat. I'll be more than happy to answer them.
Awesome. Thanks, Sahil, for the amazing presentation and session. Yeah, as Sahil said, feel free to drop your question in the chat if you have any while we still have him live. Okay, we have one.
Yeah.
Can you explain a bit? Yeah.
Yeah, for sure. So the thing is that we already, so all of these libraries like VM, Ethers, even Web3.js, all of these comes with default clients as well, right? They have default client setup. Even Rainbowkit has default client setup. So now someone may ask that why should I use QuickNode or something like QuickNode instead of just using those default clients? So the first argument would be chain coverage. So not all of those default clients would have various chain coverage because they might just support few of the most popular ones. Second one would be the oldest argument against public RPCs, that these clients or these default clients or even public RPCs are free. They can be used by anyone, they can be accessed by anyone. So that's why they are kept rate limited. And that's not bad, but they have to keep it rate limited because since they are free, anyone can use them and someone can just abuse them by sending tons of requests to them. So that's why they are rate limited. So having a dedicated RPC URL like QuickNode's URL can help you get past of those rate limits. And third is, of course, speed. You get faster blockchain interactions and faster transaction acceptability probability. I won't say your transaction will get accepted faster, but the probability of getting your transactions accepted increases since if you send a transaction using QuickNode, your transactions get propagated throughout the network of different nodes throughout the globe. So your probability of your transaction getting picked up by a validator at a location increases. So these are few of the benefits that why you can use QuickNode, why you should use QuickNode, and how it helps you for blockchain read and write operations.
Awesome. And then TP also says, it sounds that for a team that's looking to go beyond testnet, something like QuickNode is inevitable.
Yeah, for sure.
And we have one more question in. Is there any skeleton repos to get started on deploying an app similar to this quickly? Also was wondering if it's possible to integrate on React Native, Electron.js, etc.
For sure, I can quickly create a React. Like I can quickly create a GitHub repo after the workshop and send it over to the Chainlink team, and they can pass it on in the hackathon communication channel. And of course, for React Native, uh, I think most of the React apps can be shipped to React Native pretty easily. And if not React Native, you can always create a PWA, which is very easy. You just need a library and then deploy your actual app in as a PWA or post progressive web app, which works as good as a native app on your phone. You just need a PWA library, and you need to create this website or whatever website you create. You need to create that responsive. That's it. It will work as a native application.
Awesome. Thanks. I'm not seeing any other questions. So I think we can wrap the session up. Thank you so much again, Sahil, for joining us and taking the time to go on how to build, your cross-chain dApp with Chainlink CCIP. That's also super useful for our participants. And again, feel free to rewatch this as many times as you want. This will stay here on YouTube. And oh, sorry, I do see one more question. Do we still have time for one, Sahil? Are you still okay with one?
Yeah. For
The
sure.
CCIP unlock cross-chain, cross-DAO collaboration.
Yes, for sure. So DAO collaboration. I am assuming that DAO collaboration would require cross-chain token transfer and cross-chain message transfers, right? So CCIP does support that because that's what we did right now. We sent a cross-chain message, which is basically invoking a function on a smart contract deployed on a different chain. So that's possible with CCIP and you can also send tokens natively on CCIP. We, in fact, have a video on how to do that and also a guide on how to do that. Let me quickly get that so that it's easier. I will send the message to Sophia so she can paste it in the chat. So this video is on how to send cross-chain NFTs, but similarly, you can send ERC20 tokens. Yeah, even if the DAO has its own token, it's at the end of the day, it's going to be an ERC20 token, right? So the functions, whatever you write for any other ERC20 token, you will be able to use that for your DAO as well. And I think Chainlink already has examples around how to create your ERC20 token apps or ERC20 token contract with CCIP, and the process will be same. You'll have to deploy the contracts on both the source and destination chain, and then the function execution will be across chains. So there, if you go through the CCIP examples repo, there is a smart contract exactly for that. I can quickly find that if you want. But yeah, that's possible. So DAO, so basically DAO interaction will be sending tokens and sending tokens with data. So this page of CCIP documentation shows you exactly that, sending tokens or sending tokens with arbitrary data, which will be very helpful for DAO interactions or daily DAO operations.
Cool. Thank you so much, Sahil. We are on time now, but again, if you have any questions, go to our Discord channel or Hackathon Discord channel. And if you have any relevant questions, we'll make sure to pass them to Sahil. And Sahil, thanks again for joining us and taking the time. And yeah, everyone, keep building. We are so excited to see what you come up with. There's 20 days left. So if you haven't, reminder that you will need to register on hack.chain.link, but also on our dev post page in order for your project to be eligible. So if you haven't done that, go do that. And yeah, I hope everyone has a great evening, a great rest of the day, no matter where you are in the world. And we'll see you tomorrow for more block magic workshops. Bye, everyone.
Bye-bye.